Hey there, so today I'm just talking about task 2.1, the steps I took to complete it. That's to fulfill the requirements of task 2.2. So the steps are basically on the screen. Ensure the device is connected to the particle platform. Power the device up, open the LED blink sketch. I'm going to verify and flash the device with that blink sketch, make sure that one works on my device and I can see it operating. Then we're going to wire in the push button. We're going to ensure that button pulls one of the pins low or high depending on how you set up the button. We're going to figure out the definitions of Morse code for particular letters of the alphabet. I use Visual Studio 2022, the Community Edition, in order to debug my code. I found it really hard to use the native particle IDE to debug anything, and Visual Studio 2022 is set up much better. So I used a blank C++ sketch because the Arduino sketches, or the particle sketches, use Arduino. Arduino uses C++. So just set up a blank C++ project and use that to debug. Then I took and had to use some version of the code. I couldn't use all of the native libraries from Arduino in Visual Studio because most of them are built on top of the machine. They're APIs for the machine itself, or the embedded system in our case. So had to alter the code a little bit to make sure we weren't doing that and just like print stuff out in the case where we were blinking or whatever. So that's what I did. Then when I feel like the code's working in Visual Studio, I moved it over to the Particle IDE and started running the code there, and then confirmed that it was blinking the LED at the rates that sort of looked reasonable, and then just check the button works. So with all that said, the first thing I did, come in here and look for so you open up this side pan for code. The first thing you want to do is check your device is connected, so just come in here, make sure your device is connected. You might have to go through the add device if you haven't done that already. You'll have this status button here that says device connected. You can come into the code section of the panel. You need to find the example app, and then you also need to fork that application, and then it will come up under my apps. You can click that and you can close the thing down, and then you'll have these options to verify, like save, verify, and flash. So you may want to just double check that the LEDs defined here are the same as the ones you've either plugged into or are the same as the built-in ones for your case. I'm using an particle argon board, so I believe D7 is the built-in. So it's cool to leave this in. It just means that I have nothing connected, nothing. It's obviously not going to flash, but I'm expecting this built-in one to flash. So you can verify and see that the code is compiling, and then it will finish and says great work when you've done a good job. And you can click flash and it will send it over the air down to your particle board. And then you can just confirm that the LED is blinking at this rate, 1 second on, 1 second off. So these are milliseconds, not seconds. Cool, so then you're pretty sure that you've got most things set up fairly accurately, and you can move on to the next step. And the next step is basically figuring out how to meet the requirements of 2.1, which is that you can blink your name in Morse code instead of blinking at these set rates. And there's a button that has to reset it. So what I did is write the code in Visual Studio Community. So I basically just set up a new project, a blank C++ project. Obviously had to install this piece of software first. You don't have to do this, but it does make debugging much easier than you can do in the native particle IDE. So the interface, I guess in general, I approach coding in this particular fashion, right? So this C++ project is set up differently to the Particle IDE. Particle IDE has like a setup and then like a loop. This typical C++ projects have like a main, so it doesn't really matter as long as we understand how to translate between the two things. So this is effectively the step before I move it all back to particle and then start implementing the native particle libraries that actually do the blinking. So the requirements for this particular thing are we want to blink a first name or a sequence of characters, really would be the more general thing. So I'm just going to define that, right? I'm just going to define the string I want to blink. We're not going to take it from input or anything like that. I'm just going to keep it super straightforward and do exactly what the thing told me. And then there's lots of approaches to programming, but one paradigm that's fairly easy to follow is like object-oriented paradigm. So typically that means like building objects and functions inside those objects that relate to those particular objects. So that's sort of the approach I took, and there's definitely better objects written than the one I'm about to show you, but and there's definitely better approaches in terms of like memory management than the approach I'm about to show you. This could definitely be improved, but it does blink. It does meet the requirements and it does work on the particle embedded system. It doesn't use too much memory for the system. So, you know, whatever. This could probably, I could have put something like while, you know, something button state does not equal low in my case. But this isn't, I don't really need this right here. So this particular piece of code isn't actually what I submitted. It's just like some meta code so that I can debug the main class, which is this Morse class. So this is the interface that I've written. This is pretty much what I'd like to approximately write in particle. So anyway, here it is. I define a name or a sequence of characters. I deliberately put them in lowercase in an attempt to break my code. I set up this object and give it my name as input, and then I traverse that string in the object. So pretty minimal main input, main implementation, just like 3 lines of code, and all the functions happening, everything happens in Morse effectively. So I've got a class called Morse, and the public section of that class is basically a bunch of definitions, right? This first bit is just a bunch of attributes, and these actually encode the definitions for characters in Morse code. So A is like dot dash, B is like dash dot dot dot, blah blah blah, you get it. There's 26 characters, they all have different definitions, and that's the sequence that I expect the LED to blink when I input that character. There's a further definition. If you read the 2.1 task, it sends you to internationalmorse.html, and you can find out some information about Morse code, and that's basically that dashes, so that's these definitions, and there's some more for numbers, and also that dashes represent 3 times the amount that dots do. So dot dash is ambiguous, you know, dash is 3 times longer than dot, basically. Then I've got this uninitialized name, which is just a string that comes in, and I've passed it by value, not by reference. So there's definitely optimizations that could be done here, and whatever, it works for this case. And basically I initialize this Morse object. Name gets put into this variable at construction time, and then I'm basically just traversing whatever this particular function here takes the string, which is the name that I passed in at initialization, traverses it, reads the characters off one at a time. It turns them to uppercase and then compares them to this character, basically. So if it's equal to that character, then we're going to read the sequence of this variable up here called A in this case. So if it's A, read A, if it's B, read B, etc. And in this Visual Studio world, I'm just going to print them out. I'm just going to print out that dash and dot. So this isn't actually the final code. This is just like the metacode, like I keep saying. So what this does is let me run the local Windows debugger, and I can see that if I do that, it'll compile up, build the code, and it'll stop right here. So I can come into my my class definition, step through its functionality, and make sure everything that I think's happening really is happening. And I've got these like nice options, right? Like watch windows and stack traces and whatever. I can see what's happening in memory. blah blah blah. So yep, I can just like step through, which is this button up here, or F11, and just make sure that all these definitions are being loaded into my class. Then the Morse constructor takes a name, puts it in this name, and we got traverse the string, and it does, it comes through, traverses the string and reads off the sequence. And if you've got a console window open, you can see that it is reading the sequence and printing out dot dash. So that's the gist, right? I did this first, I wrote it in Visual Studio Community, so that I could debug effectively. The next step is bringing all of this logic or this class definition back to Particle IDE. So I've effectively copy and pasted it back to Particle's native IDE. And the reason for doing that is obviously I need those native libraries to flash down. And there are ways you can actually build this code in Visual Studio Code or Visual Studio Community and flash it down that way. But I didn't really want to get all into the setup considering I'm going to use this like one time. So I've just copied and pasted it across, with the exception that where before I was, so all this is the same, right? I've changed some method names. I think they're more readable. It's all semantics, it doesn't matter. But basically, A still calls A, B still reads B, blah, blah, blah. And in the read sequence method, I'm checking if the sequence is a 1 or a 0, and then calling a new method, which is called blink, and pushing into it this dot dash, this dot dot, depending on if it's 1 or 0. So the method blink actually handles the blinking of the LED. So it's literally just digital write high, digital write low with a time delay. And there's some additional functionality that I've discovered in Morse code, that is the space between dots and dashes is also defined as 1 unit. So I really could have put this, like instead of putting this space, I could have used this dot, but I figured, more general is whatever. It is what it is. I use this space, so space is changeable independent of dot now. So if for some reason Morse code definitions change, you could just change the definitions. But anyway, whatever. So that's pretty much the gist, right? This particular thing, so now instead of Morse is almost the same, I've added this extra blink, which just handles pulling the LED high and low for particular time periods. And this looks different. This, so setup, like I was describing earlier, setup and loop are like embedded system thing, or like Arduino things really. Main is like a C++ thing, but effectively loop is main, except that it just goes over and over again until you exit or it breaks. So the thing that I've had to add here is that I want to read a button now. So I've initialized the button. You can see I've initialized the button as D3, which is what I wired into. The onboard LED is still D7. I have to read the button, and then the state of the button is either low or high. In my case, it's a pull-up resistor, so if the button goes low, I know the button's being pressed. And while that's not the case, if the button's not being pressed, we're just going to blink the string. And if it's low, it stops. So that's pretty much the gist of it. Some things, I guess, about it is the string that you put in. I've typed in, typical capitalization name. This is going to work regardless of case, because I've sent these all to uppercase in here somewhere, right here. In blink string, they all get sent to uppercase, but you can break this thing if you send in some unknown character. I haven't handled the cases of like numbers or weird characters like spaces or whatever. Basically, they just won't get read. So if it doesn't have a definition in Morse code, or specifically if it doesn't have a definition in my definitions for Morse code, then it will not get read. Yep, that's pretty much the gist. All right, yeah. So you upload this, you put your version of this in. You verify it with this little button here. It tells you whether it's going to compile or not. Takes a second, but you can see, it gives me the feedback. Great work. You can flash it down. That takes a second, and then it'll be sitting, in the memory of the particle argon, and it'll start flashing your name in Morse code, or it'll start flashing whatever string you put here in Morse code. So fairly adaptable in terms of being able to rewrite the string. You can just type in your last name here. You'll have to flash it again, which, not great, but whatever. You flash it again with the last name and it'll blink a different string, basically. So this is pretty, in terms of meeting the requirements of 2.1, it's okay. It does what it does, and it can blink some arbitrary alphabetical string thing. What I would say about it is, in general, it's probably not a great idea to have your code sitting in the native particle IDE only. Like, how am I going to source control this? It's probably not the best. And in terms of like unit testing it, like there's no real mechanism to perform unit testing in particle IDE, at least that I know about. And truth be told, unit testing C++ in general is a bit painful in my opinion, but there are things like Google Test you can use in back-end community. But yeah, so like you'd have to set up some like framework for performing the unit testing, which in terms of modularity, there's a class here. In terms of adaptability, unit testing is quite hard, so you'd have to set up some framework for doing that stuff if you want to use the words this code is adaptable to something, or you truly understand the limitations of it. It's pretty hard to say that right now because there's no real mechanism by which you can figure out what the limitations of it are. In any case, it seems to be working for this particular use case. So that's where I'm going to leave it right now. Hope it helped a little bit. Thanks.